Hi guys, in this video we are going to discuss the problem from the contest 327 of LeetCode. The problem's name is make number of distinct character equal. The problem states that you are given a zero index string word1 and word2. A move consists of choosing two indices I and j such that the indices are valid, so they are not like going below the minimum count or above the minimum count, and then we have to swap the two characters on those different words. Return true if it's possible to get the number of distinct characters in word1 and word2 be equal with exactly one move. So it shouldn't be the case that you're not applying a move and still if they're equal, then that's not a valid answer. You should be able to apply exactly one move and then the number of distinct characters in both the strings should be equal. So how should we do this? So might be in the first go you think that order of n square won't work, and that's correct. Order of n square won't work over here. Then it's possible that you start using complex things like I did in the contest. Even that would work, but that would take a lot of time to code up. So for reference, this is my code that I used in the contest. Okay, so this is the one I actually submitted in the contest. Yes, it is AC, but you can see see the length of this code. This is pretty long. Although this is more optimal time, like in terms of time complexity, but definitely it's not the way you should be doing it. There's a much better way of doing it. We'll explain that in this video. So let's get started. So let's say I have two words, right? So this is my word 1, this is my word 2. So how many characters are there in the English alphabet? So in the English alphabet we have a total of 26 characters. So that would mean if we count the frequency of all the characters in it, so the hash map or the map or the vector, whatever we are going to store it in, won't exceed 26. It also won't exceed 26, right? Pretty simple. Then we can check for all the combinations. So all the combinations would actually be of the order 26 into 26. This is a small number, definitely can be checked. So we'll check for all the possibilities that can I replace a with a B or a B with a C, all of that sort of possibilities. When we get a match, that when we see that after considering this particular operation or any operation, so let's generalize it that I want to replace a character I with a character j. So this I character is in word 1, and this j character is in word 2. When we replace the characters, then the frequency of distinct characters in both the strings become equal. If we get the scenario, then we can return 1 or return true. If this never happens, then we'll have to return 0. So it's as easy as that, and the code is also pretty simple. Let's look at the code. So the code is that firstly I'm taking an ordered map of character int. It would be used to store the frequencies, and in this what we are doing is firstly we are storing the frequencies and then I'm taking the sizes. So this means the size of a, and the size of a would in turn mean the number of distinct elements that are present in the word 1. The size of b would mean the number of distinct elements that are present in word 2. After that I'm traversing over all the distinct elements. So these are all the distinct elements in word 1. So when I say C1 F1, so what I mean is that C1 is the element or the character and F1 is its frequency. So I'll be doing this for word 1. Then I'll be traversing for all the characters in word 2 as well. So C2 is the word and the F2 is its frequency. I'll be checking is C1 and C2 equal, and size B is not equal to size A. So technically they won't make any difference, because if I'm replacing this A, I'm replacing the same character in word 1. Let's say I'm replacing A in word 1 with A in word 2, then they technically don't make any difference, right? So they can only return true if their initial sizes or initial distinct element count was actually same. So if that's not the case, then this operation doesn't help me. I'll simply continue over here itself. If this is not the case, then what I can say is that after replacing that elements, if I'm getting equal number of distinct elements, only in that case I'll be returning 0. So how can I calculate that? So there's an easy way to calculate that as well. I could have done a lot of computations over here, but this is a much linear code, and it would definitely save time if you code in such a manner in the contest. So what you can say, so size A is the number of distinct elements you were having initially, minus now you are like moving your character C1 to C2. So in case C1 was only available one time, right? So there was only one occurrence of C1 in A in that case you'll have to decrease this number of distinct elements in A by 1. That's what we are doing over here. So if the frequency of C1 was 1, then we remove like decrease size by 1. So what this technically means is this is a ternary operator. This means that if f1 is equal to 1, then give me 1. If it's not, then give me 2, then give me 0. So this is what a ternary operator does. It basically like reduces your code size. So if I had not used this, I would have used a lot of ifs and else statements. So that doesn't make sense. This is a pretty neat line of code, I'll say. After that, what I have to check is that if your A already had the element C2, which you are now going to put into A, so then it won't make a difference, right? Because if you have one elements of some type, or like maybe 100 elements or 100 characters of the same type, it won't make any difference. But if you didn't have that element earlier, then your distinct count is going to increase by 1. So that's what I'm doing over here. If A already contained C2, then don't add anything. If it didn't contain C2, then add 1. Same I'm doing for size B as well. So size B minus, if the frequency of the element was 1, which I'm moving, then I have to subtract it. Else I'll just not subtract anything. Now if the character I'm adding at my word B, if it was already present in word, then do nothing. Else increase my frequency by 1 or increase my district count by 1. If these two things now become equal, that means after performing this operation of interchanging the characters in word 1 and word 2, I'm getting equal number of distinct elements in both the words. Then I'll return 1. Else, if I'm able to go through all the possible combination, that is 26 into 26, and I still don't get a valid answer, I'll be returning a 0. Let's try submitting this up. Cool, and this works. So yeah, in implementation based questions, you should always try to like write a linear code. If you want, then before even like starting with the solution itself or starting to code, you should think about it, like how can I make it linear? Because the thing is, like, let's say I have to code 10 lines for a single logic. That would take time, right? It's better to think for 1 minute in order to save that time. So yeah, that's about this video. Let me know if you have any questions. I'll definitely try to answer them. Thanks a lot, guys. Bye bye.